What's up guys, it's me, Sir Ernest, and today we're going to solve problem 7.4 of Fowles and Cassiday 7th edition. The problem reads, a block of wood rests on a smooth horizontal table, a gun is fired horizontally at the block, and the bullet passes through the block, emerging with half its initial speed just before it entered the block. Show that the fraction of the initial kinetic energy of the bullet that is lost as frictional heat is 3/4 minus 3/4 gamma, where gamma is the ratio of the mass of the bullet to the mass of the block, assuming that gamma is less than 1. Okay, so as I mentioned here, gamma is equal to the mass of the bullet divided by the mass of the block. If this is less than 1, so that means the mass of the bullet is less than the mass of the block. Okay, so before collision, this block is being approached by your bullet. So let's say the mass of the bullet is m1 and the mass of the block is m2. So the block is resting, so that means the initial velocity of the block is 0, while the velocity of the bullet is not equal to 0. So let's call that v1. And then after collision, this is before, this is after collision, the block will start to move. So let's call that U2. However, during collision, the bullet passes through the block. So that means the block is continuously moving in the same direction as before. This is U1. Okay, but U1, that's the speed of the bullet as it emerged from the block or off the block, and the speed is just half of the initial speed. So this means that this would be 1/2 v1. So these are some of the clues that we can use during our calculations. Now, conservation of momentum tells us, okay, so conservation of momentum tells us that m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2, because v2 is 0, so this term is cancelled, and then u1 will be v1 over 2. So this becomes m1 v1 equals m1 v1 over 2 plus m2 u2. Okay, so combining this equation or manipulating this equation, we can express u2 to be equal to 1/2 m1 over m2 v1. So we already know that m1 over m2 is gamma. Remember, we already said that mass of the bullet would be m1 and mass of the block would be m2. So this is now equal to 1/2 gamma v1. Now, as mentioned here, we want to find the kinetic energy that was lost. So we're looking at Ti minus Tf divided by the original kinetic energy. So we're looking for this. So remember that before collision, only the bullet is the one that moves. So the total kinetic energy of the system is carried by the bullet. Okay, so now let's compute for the kinetic energy loss. So Ti minus Tf, so this is the kinetic energy loss. This is the percentage of the loss as heat. So this will be 1/2 m1 v1 squared minus the total kinetic energy after collision. So this means the kinetic energy of the block of the bullet, so that's 1/2 m1 u1 squared plus the kinetic energy of the block. So after this, using this relationship and using this relationship, we can rewrite this as 1/2 m1 v1 squared minus 1/2 m1 v1 over 2 squared plus 1/2 m2 times u2 squared. So this is 1/2 m1 over m2 v1 squared, which is equal to 1/2 m1 v1 squared minus, this is 1/8 m1 v1 squared, and this will be minus 1/8 m1 squared over m2 v1 squared, and this is equal to, okay, combining everything, we now have 1/2 m1 v1 squared, so factoring out 1/2 mv1 squared, and this becomes 1/4 1 minus 1/4 minus 1/4 m1 over m2, okay, which gives us 1/2 m1 v1 squared. This would be 3/4, sorry about that, this should be 3/4 minus 1/4 gamma. So therefore, since remember that Ti is equal to 1/2 m1 v1 squared, so therefore Ti minus Tf over Ti is equal to 3/4 minus 1/4 gamma. Okay, so that's it. That's your solution to problem 7.4 of Fowles and Cassiday 7th edition. Thank you guys for watching, and I'll see you guys in the next video. Bye bye.